Okay, this is the explanatory video for the worksheets I put in the Google Classroom for Book 2, Chapter 6. So to begin with, we need to remind ourselves that there will be different types of questions. The first type is when there is no other forces acting on it except the gravitational force. We usually would have the loss in PE, which is equal to the gain in KE when it goes downward. Or when it goes upward, it will be opposite. The gain in PE should be equal to the loss in KE when it go upward and when it go downward. So you may just imagine there will be an exchange of potential energy and kinetic energy. So for the first question, when there's an object dropping from X to the position Y, so obviously there's no other force acting on it except the gravitational force that would be affecting the energy, right? So in that case, we should use loss in PE equal to gain in KE. So that is mgh equal to half mv squared. We are looking for this v. So first we may cancel this m, and then we have 2gh, put the 2 to the other side, equal to v squared. And the next step is v equal to square root 2gh. In fact, for all free falling objects, you may use this directly to find the answer. So after that, we may just substitute the numbers into it, and v equal to square root 2 times 9.81 times, it should be 0.1. 2. Instead of fooling around. And the h is 0.2, right? 2gh. So after you do a calculation, it would be 1.98 something, around 2 meters per second. So the answer should be A. Okay, so this is the first question. Now, so remember this, whenever we are doing a question without any other forces like friction or a pushing force, we will be making use of that, okay? So next question. A ball of mass 2.5 kg is dropped from the height 4 meters. So in this case, there's no other force, right? So again, we may use loss in PE, which is equal to gain in KE. And now the question is just like asking you the KE gain. So that means you may just do it like gain in KE is directly equal to this. This is mgh. So we just put the number. The mass is 0.5, 9.81 times height is 4. So that means you will have an answer that is equal to around 20. You may wonder why you got the number that is not exactly 20, because I got the question from the old syllabus, and you may use 10 for that, but I just want to avoid confusion. I'll keep using 9.81, so you have this number. So answer C for the second question. So for the third question, it's a little bit more complicated because it involves more than one object. So in this case, there are M1 and M2 connected through a string over a pulley, and M1 goes up for a certain distance h. But you may imagine, since they are connected by a piece of string, the distance that the M1 goes up should be equal to the mass M2 goes downward. So what we are talking about is there will be a gain in PE from M1, you gain in PE for M1, but loss in PE for M2. Okay, let's see whether the following questions are correct. Number 1, potential energy gained by M1 is mgh, M1gh. It has to be correct, right? Because it just moved up by a distance h. So it would gain by M1gh. And for the mass 2, it lost the potential energy by M2gh is also correct. But notice that these two values should not be the same, because it will set the whole system into movement. So that means there will be some energy gain in KE for both of the object. So what we should know that is loss in PE by M2. Now this mass is losing PE, right? And the loss of this PE should be, some of that would goes to the gain in PE by M1. Besides, there would be also gain in KE by both of them, 1 and M2. So both of them will gain some PE due to the loss of PE by this. So what I mean is, this mass would be like giving out some energy by losing its PE to the gain of PE by M1, and also become some kinetic energy of both of the objects. So the third one should not be the same, because we need to take the gain in KE into the consideration. So this is the question 3, 1 and 2. Alright, so then the next one is a block is pulled by a horizontal along the horizontal bench with a constant velocity, 5 meters per second, with a force like that. So we define the work done in these 2 seconds. So what we are going to do is to find the work done, right? So work done has an equation which is equal to force times distance. So the question already gave you that the force should be 8, right? But how far it is traveling, this is displacement of the block. So you need only 2 information, the force and displacements, but we don't have the displacement yet, right? So what's the displacement? We know that now it's moving at constant velocity, 5 meters per second. That means it will travel by 5 meters in 1 second. And now it travels for 2 seconds. So this is what we are going to do. It should be equal to displacement equal to velocity times time, so which is 5 times 2 equal to 10 meters. So since it moved by 10 meters, we may just put it in the displacement here. So the product of that would become 80 joule. So answer is A. So this is question 4. Okay, let's continue. Question 5. There's a 15 kilogram box placed on the horizontal plane, which is pushed by a man by a horizontal force. Okay, so that is a block pushed by a force with 40 Newton force forward, and it travels for a 30 meter, and the time taken is 1 minute, which is 60 seconds. Now the question is asking for the power. Now for power, we got another equation, so we should be very familiar with these equations, which is work divided by time. So now the work done should be equal to the force times displacement and divided by the time. So we got everything ready. This is the force we provide to the block, 40, and it travels for 30 meters. And then we divide by the time, 60. So that's what we have. So you may use your calculator to find the answer. So I may just do it directly. So which is equal to 20 watts. So answer is B for Boeing. Finally, the last one. A student of mass 60 kilogram runs up a flight of stairs 25 meters high in 30 seconds with uniform velocity, uniform speed. So what is the power developed by the student? So again, power is equal to work divided by time. But notice that in this question, you're not pushing an object along a certain distance. It's talking about a student going up, right? So we may use work equal to the gain in PE in this case, because the work done by the student is has all goes to the PE of the student. Since there's a uniform velocity, there's no PE gain. Oh, sorry, no KE gain, right? It has the same KE, so that means all the work you did would all goes to the PE. Then you divide by time. So we may do the calculation by putting mgh to the gain PE, which is 60 times 9.81 times 25, and then you divide by the time taken, which is 30 seconds. So you may just follow one by one. You got all the information you have. So it would be like 50 times 9.81. So I guess the answer should be 500. You may check with the answer. It should be B, okay? It should be around 500 watts. Okay, so this is the first part of the MC question. I would put another video for the part 2, the long questions. See you.